Consider a box sitting on a table. It is at rest, so Newton's laws of motion tell us that forces up equal forces down, and forces to the left equal forces to the right. The force down is the object's weight, and the force up is the reaction force, Rn, in opposition to the forces pushing the box and table surfaces together. In this case, that would be the weight of the box. There are no forces to the left or right. Now let's try to pull the box across the table with a force applied parallel to the table. We'll call the force Fa. At first the box remains at rest, so we know there has to be a reaction force opposing our applied force. This reaction force is the friction force, Ff, and it acts to resist sliding motion and is due to the irregularities between the surface of the box and the table. Friction is the opposition to a sliding movement caused by the irregularities between two surfaces. The magnitude of the opposition to sliding will depend on the amount and severity of the irregularities between the two surfaces, the measurement of which is called the coefficient of friction. To slide an object across ice where a film of water separates the object from the ice requires a smaller applied force. Therefore, the coefficient of friction is small. To slide the same object across asphalt will require more force because the coefficient of friction is high. Actually, for every sliding scenario, there are two coefficients of friction. One to start an object sliding, and another to keep it sliding at constant linear velocity. The coefficient to start an object sliding is called the coefficient of static friction, and is given the symbol US. The coefficient to keep the object sliding at constant velocity is called the coefficient of kinetic friction, and is given the symbol UK. For the same two objects, US has a greater value than UK because it takes less force to keep an object sliding than it takes to start it sliding. Friction force is the reaction force that opposes the effort to slide one body over another. Since it is a reaction force, it has a maximum magnitude it can generate to oppose the applied force. The friction force will oppose an applied force to start an object sliding up to its maximum value. Then if the applied force is increased, the applied force will be greater than the friction force. The maximum friction force the system can offer to oppose sliding can be found from the formula Ff max equals U times Rn, where Ff max is the maximum friction force and U the coefficient of friction. For every system, there will be two maximum friction forces, one to start the object sliding and one to keep the object sliding. This is because there are two coefficients of friction. So we can say the maximum static friction force equals the coefficient of static friction times Rn, and the maximum kinetic friction force equals the coefficient of kinetic friction times Rn. It is important to understand that friction force is a reaction force and will equal the force trying to slide an object up to its maximum value, Ff max. Example 1. An object has a weight of 1,000 newtons. The coefficient of static friction equals 0.3 and the coefficient of kinetic friction 0.23. What is the maximum static friction force and the maximum kinetic friction force? Assume the object is on a horizontal surface. Example 1. An object has a weight of 1,000 newtons. Coefficient of static friction is 0.3. Coefficient of kinetic friction equals 0.23. What is the maximum static friction force and maximum kinetic friction force? Step 1. Finding Rn. Since the object is on a horizontal surface, the weight is vertical to the surface, and since there are no other vertical applied forces, Rn equals the weight, or W, so Rn equals 1,000 newtons. Step 2. Finding the maximum static friction force. The maximum static friction force equals the coefficient of static friction times Rn. Maximum static friction force equals 0.3 times 1,000 newtons. Maximum static friction force equals 300 newtons. So if we apply a sliding force of 100 newtons, our static friction force will match the applied force and be 100 newtons. If we apply a sliding force of 300 newtons, we will oppose the applied force with our maximum static friction force of 300 newtons. If we apply a constant force greater than 300 newtons, the applied force will be greater than the opposing maximum static friction force, and the object will accelerate in the direction of the applied force. So in the diagram here, we have an applied force of 400 newtons. Our maximum static friction force is 300 newtons. So if we kept applying the force of 400 newtons, the object would start to slide and then accelerate. The acceleration force would be the difference between the applied force and the maximum static friction force. Step 3. Finding the maximum kinetic friction force. Maximum kinetic friction force equals the coefficient of kinetic friction times Rn. Maximum kinetic friction force equals 0.23 times 1,000 newtons. Maximum kinetic friction force equals 230 newtons. Because the coefficient of kinetic friction is less than the coefficient of static friction, then the maximum kinetic friction force is less than the maximum static friction force. In this case, the static friction force, maximum static friction force is 300 newtons, and the maximum kinetic friction force equals 230 newtons. Since the coefficient of kinetic friction is less than the coefficient of static friction, the maximum static friction force is greater than the maximum kinetic friction force offered for the same object. So if we apply enough force to start an object moving, the maximum static friction force, and keep this force applied once the object starts to move, the object would accelerate. This is because the applied force will be greater than the kinetic maximum friction force. Example 2. A 100-kilogram crate sits on the floor. The coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.3. What will happen to the crate if the applied force required to start the crate sliding remains applied once the crate starts to move? Example 2. A 100-kilogram crate sits on the floor. The coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.3. What will happen to the crate if the applied force required to start the crate sliding remains applied once the crate starts to move? Step 1. Finding the object's weight. Weight equals mass times g. Weight equals 100 kilograms times 9.81 meters per second squared. The weight equals 981 newtons. Step 2. Finding the normal reaction force, Rn. Since the only vertical forces are the weight down and the normal reaction force up, then Rn equals the weight, so Rn equals 981 newtons. Step 3. Finding the maximum static friction force. Maximum static friction force equals the coefficient of static friction times Rn. Maximum static friction force equals 0.4 times 981 newtons. Maximum static friction force equals 392.4 newtons. Step 4. Finding the applied force required to start the crate moving. And we're going to call that applied force static, FA static. Since the force required to start the crate moving is slightly greater than the maximum static friction force, we will say that the applied force required to start the crate moving equals the maximum static friction force. So, FA static will equal 392.4, which is the maximum static friction force. Step 5. Finding the maximum kinetic friction force. Maximum kinetic friction force equals the coefficient of kinetic friction times Rn. The maximum kinetic friction force equals 0.3 times 981 newtons. The maximum kinetic friction force equals 294.3 newtons. Step 6. Finding the applied sliding force required to keep the crate moving. And we're going to call that the applied force kinetic, FA kinetic. To keep the crate moving, FA kinetic equals the maximum kinetic friction force. So, FA kinetic will equal 294.3. Step 7. Finding the acceleration force. The acceleration force equals the force applied to the crate once it's moving minus the force required to move the crate at constant velocity. So the acceleration force will equal the applied force to start the crate moving, FA static, minus the applied force to keep the crate moving, FA kinetic. So the acceleration force will equal 392.4 newtons minus 294.3 newtons. So the acceleration force will equal 98.1 newtons. Step 8. Finding the acceleration. Acceleration equals the acceleration force divided by the mass. Acceleration equals 98.1 newtons divided by 100 kilograms. So the acceleration works out to 0.981 meters per second squared. So in conclusion, we can say if we keep applying the force required to start the crate moving, once it starts moving, it will accelerate at a rate of 0.981 meters per second squared in the direction of the applied force.